think that my parents were crucial in fostering my interest for science. I grew up taking electronics apart or playing with chemistry sets, or sometimes just in the backyard looking at leaves, insects, or dirt in a little microscope. And later, being a son of a civil engineer and a science teacher, I always had age-appropriate and interesting material to read. So that went long ways to get me interested in science. And later, of course, with the space shuttle launches were big on TV when I was young. So yeah, I knew what I wanted to do. I'm a hydrologist. I study rivers and river processes. I'm interested on how flood waves propagate through the landscape and how those flood waves mold the landscape. My technique of choice is analysis of remote sensing imagery, either obtained through satellites or manned or unmanned airplanes. Most of my job takes place into my office. It's not very glamorous. I don't get to go to the field as much as I would like to, but I believe it's also an important part of the work, which is interpreting the remote sensing information. Remote sensing information is often suffers from uncertainties, from errors that can be either deterministic biases or just random errors. So a big part of my job is discerning what are the errors from what are actually river properties that can be taken from this data. The reason why I work with the Sacramento River and the Po rivers in Italy is because I have highly detailed hydraulic models of both rivers. So other reasons are that the Po River is quite wide. It's about 300 to 400 meters wide in a normal discharge year. So that is the sweet spot for SWOT. So if we want to know how SWOT is going to perform, it's going to perform on average like it does with Po. Sacramento, the section of the Sacramento where I'm working is very narrow, and it's constrained by levees. Levees are narrow rivers constrained by levees are one of the worst case scenarios for SWOT. If we are going to see high biases on the signal, it's going to be in that situation. Water is crucial for sustaining our cities, our agricultural industrial production, and any ecosystem in general. So, but the timing and the rate at which water reaches us is really crucial. It can be if it comes too much too fast, then water has incredible destructive power. If it don't come at enough rate or at not enough quantity, then you can have problems such as forced migrations or, at the very least, decreased productivity. So knowing how fast and being able to predict how much water you're going to receive at any given location is really important for society, I believe. Well, being at Byrd and at OSU allows me to work with leading scientists in the field. Here at Byrd, I have the opportunity to interact with, for example, Professors Michael Duran and Doug Alsdorf. Professor Alsdorf was, as a matter of fact, he was one of the driving forces between the mission that is really the basis of my work. So if I wasn't here, I don't know where I would be able to do my research as well. And besides, OSU houses the Ohio Supercomputer Center, so all the infrastructure that I need to perform my calculations are just within reach.